Hello. Three-stage Boolean, right? Okay.
Ale víš si dať subscription v základe sviat mesačne na Partitioning. Presne, áno.
Hello. Yeah, works. So, second topic is about build automation. Who knows what build automation is? Yeah. Who wants to give a definition? Exactly. First prize. You get a bottle of water. Well, build automation is like the process of delivering software, for me at least. It's not about compiling a solution, but compiling a solution is part of build automation for me. Like, additional tasks would include something like creating NUKE packages, deploying your website, stuff like that. Okay? Or announcing something that a new version is available, stuff like that. My background for that is I used MS-Build before, but MS-Build isn't really handy for that, so you can actually extend MS-Build also with custom tasks. You can introduce new targets and stuff like that, but it's not handy. I think if you want to do path concatenation, so just putting two paths together, it takes like 6 lines of code in XML. Also, you can't do anything about like logically, I mean imperative code, filtering and stuff like that. It's really hard. Then I use PowerShell, but PowerShell has some additional surprises, like unknown unknowns, so things that you don't know, or you won't know, or whatever. And you don't want to know, like the thing that I mentioned earlier about null comparison, or what was particularly surprising with PowerShell was when it unwraps, or you have a collection and you're piping something and there's only one element left, and it will happily convert into one element. So you only have the element and not the array with one element. So you have to force it to keep it an array. The default is it will unfold the element. Very, very funky thing. I skipped fake. Who knows what fake is? Fake is, you all know what makefiles are from the Unix world, right? Fake is like make, but for F#. F# is the host language. And why I skipped it? Well, because it's F#. Not because I don't like F#, but because I don't know F#. That's the reason. And fake might be nice, I have no idea. But in the end, if you establish build automation in your company, everyone wants to be, maybe not wants to be, but should be able to work with the build automation parts of your system. And if you're using fake, you're introducing an implicit requirement, basically, that people know F#. Okay, learning curve. Who knows cake? Okay. Who uses cake? You're also using it. Okay. I want to convert you, at least.
Well, I don't use it by choice. So.
Have you heard that? Not by choice. Okay, so let's see how many will use NUKE as by choice. The issue with cake is that it's still a scripting approach. Do I really need to use the microphone?
Not for me.
Yeah, it's still a scripting approach. You have to do, you have to install extensions and all that stuff just to make it, just to make it mildly work. Like for instance, if you want to have code completion or debugging, it doesn't work like that out of the box. You have to invest something. You have to read tutorials about that and stuff like that. So it's still not exactly great. So I gave that presentation already at a conference in Kiev, and I subtitled it 10 ingredients for an AKEless build system. I will probably skip a few. I don't know, maybe not. But yeah, that joke is not from me, but from this nice guy over there, Nikolai. And yeah, let's start with the ingredients. The first one, NUKE is a console application. So if you look at that, at it for the first time, it's really a build project actually. We don't call it build script anymore. Okay, notice that? Project, not script. And it's an actual class also. So here the build inherits from the NUKE build base class. You can also see it's actually a console application. So you have this static int main as the entry point. So you can be sure you can work with that. Everyone used a console application before. We didn't use a console application before. Wrong meetup. Or maybe not. We still learn. But anyways, it basically just delegates to another method, a static method that comes with the NUKE build base class, and passes some information about the type. You know, it's just the entry point basically, and also passes the default target. In this case, it's world. And usually, with every new tool, you want to do the hello world example, right? In this case, it's not that clearly a hello world example. But in build automation, there's the common practice of defining target dependencies. So for instance, in order to publish your packages, you first need to pack them. You need to create them. In this case, world just depends on hello. So hello will be executed before world. And since in the output there will be also the target names being written, you would end up with something like hello and world. All right. Like I said, debugging would work just like that. So here, for the implementation of the hello world target, for instance, there's a delegate here with curly braces here and there, and I could just put the cursor there and then implement the hello target, and then also put a breakpoint there, and it would just run. But there's one very big difference compared to others. Someone noticed that already? To other build systems? Yes, it's C#, yes. Okay, I'll just say it. Hello and world, they are actual symbols. There are no strings. In Cake, you have strings. In Cake, you could, for instance, if you have a target which is called, never can say this right, initialization. Yeah, you can write with an S or a Z. It's hard to catch, right? And even if you change the name, for instance, which is a common thing to do, the other occurrences don't update automatically. Here they will. If I put the caret here on world and I invoke writer and want to rename that, then this gets updated as well. Or if I rename hello, then this usage will get updated as well. Right? And you always have working code consistently. And you can also navigate to that. If you're somewhere in your solution and you see it's the full solution that I have here, and I want to navigate to the world target, I just type build.hello and I just jump to the target. So very easy to navigate also. And I like to do quizzes. So somebody please tell me what actually is hello? I mean, as a symbol. What is it? Yes? want to continue? Because there's this, tail.
Of target, what this target is a friendly function.
Target is a delegate.
Yes.
Yeah. So the first arrow is expression-bodied property. The second is because target is a delegate, right? And I will tell you, many people complain about this tail. I have no idea what they want. But yeah, it's basically opening up some kind of fluent API right here, where you can write depends on and executes and a bunch of other things. But this is really, in my opinion, this is really nothing to care about that much. But it catches people's eyes, apparently, if I talk about that. Okay, second thing is tool support. And the thing about tool support, and by tool support I mean third-party tools like XUnit, NUnit. MS-Build also has the CLI or .NET CLI, Octopus.exe, stuff like that. Usually you want to incorporate that into your build at some point, when you get Extra and what else not, or Docker. And many of the other build systems, especially Kate and Fake, they wrote support for such tools in a manual manner. So they came up like, okay, there's this command which is called .NET build, and then I want to modify arguments like the project path, for instance, and they implemented that all manually. And because it's manually implemented, it's also hard to maintain and hard to scale for certain CLI tools. Like Docker has such a large interface. I mean, speaking from how you work with it on the command line, it's impossible to do that if you're doing things manually. I will come back to that in a moment, but this is, and I'm not for nukes, but for that particular purpose was nice to kind of show it with that workload. But this is the ecosystem of Nuke right now, what things are supported. Somebody misses anything? Huh? Yeah, I did that so it looks like more.
Service fabric.
Service fabric, yeah, okay. But I will get to that in a moment, actually. Not service fabric in particular, but how to add support for that. Here's how you do things in Nuke. So if you want to call .NET build, for instance, I mean .NET, then space and build as a command, you can do this in Nuke by typing first initial letters, and then it will complete. So that would call it .NET build. Okay. Second, if you want to modify certain arguments, you can use the Fluent API, like for instance set project file, and then pass the solution. Or we can enable the no restore flag. Enable no restore. All right. But notice also there are other methods as well, like disable or toggle. They exist basically for composition of different settings. Like sometimes you want to invoke almost the same process, but with different project file, for instance. But the configuration is the same. The version is the same, just the project file is different, right? So in those cases, this Fluent API is helpful, because also with every call, we get a new object. It's like a copy of the original object. And also for verbosity, and verbosity, as you may know, has a defined set of values that can be accepted. And in this case, you would just tell you this and that value is available here, or is possible. Also, if you invoke documentation for the different methods, it will have the same documentation as in the original MS-Build documentation. The very same. And not just for Microsoft tools, but also for Octopus, it would have the same documentation as from the original site. And like I said, they're doing things manually. In Nuke, this is what I actually write to bring support for .NET, for instance. we're gathering metadata for command line tools. So for instance, we've seen project file, and project file, it's just simple as that, it's just a string. And if we want to set the project file, then on the command line it should just be passed without any additional arguments in front of it. Whereas configuration, for instance, has minus minus configuration and then the value. But from this information, from this metadata information, we generate the complete API for working with such CLI tools. Restore, for instance, is a Boolean and has minus minus no restore. Okay. Then I already talked about that, but composition, this Fluent API allows composition. So for instance, this is applied definitely, the project file and configuration, but only when published test results is true, it's a Boolean, then this additional modifications will be executed and printed also on command line or on the invocation. Not printed, but you get what I mean. This is another example, and also mentioned it already. If you push packages, then the source is the same, symbol source is the same, API key is the same, but the package is different. And so NUKE has the ability to combine with different values, but for the same property basically. And here we're just gathering all the NUKE packages and setting the target path to the same invocation. And also you see it allows to have a degree of parallelism. So in this case, 5 will be sent simultaneously. And all of the invocations will be completed even if the first has a failure or the second has a failure. That's sometimes meaningful if, for instance, you executed the push of or the publish of targets already, but one failed, and you just want to re-execute it to push that one missing package, then you don't need to modify anything or skip something. It will just re-execute and that's it. That's, for instance, how this publish works locally for NUKE as a project. You see the invocation in kind of blue, and it gets executed immediately, and only then afterwards you see all the different outputs for the different invocations. Okay. But then also for some tools that's not really meaningful to do so. Like with Git, I don't want to use that Fluent API. I think everyone agrees I don't want to have enable, force, and stuff like that. It's a bit cumbersome. So we have this thing called Lightweigh Resolution. And Lightweigh Resolution is basically just you're defining fields of type tool, and tool is delegate. We will see in a moment how it's being used. And we can resolve tools from different sources, like for instance from the path environment variable, from an actual path, or from a NuGet package. Okay? So I use the package ID and the executable. And that, in action, it looks like that. We can use string interpolation, and then do git checkout on the master branch and stuff like that. So this is really, I think, maintainable. It's not like a long string of stuff that you can't deal with, and well, sometimes people probably still want to concatenate strings and stuff like that, but especially in that case, I would always recommend to go back to this thing with the composition, because it reads much nicer, at least in my opinion. Okay. And for the NuGet dependencies, so if you're working with XUnit, we still require you to put that into the build CS project file, because otherwise the reproducibility of your build is not guaranteed. So there was the idea to download tools automatically, but NuGet could cache, for instance, versions, and it could, on one machine, resolve to one version, on another to another version, and then you're sitting in front of it and you don't know what happens. And we want to get rid of that. So you just define the version, and that's it's not a big deal. Third thing is path handling. And one thing that that really annoyed me before when I was using other tools is if you have some kind of relative path, you pass it to a tool, and just because you're in a different working directory, something doesn't work. It's really annoying, right? Who can feel me? Everyone? Okay. So the idea in NUKE is to provide absolute paths all the time. Let's go back for a second. To provide absolute paths all the time, and that by default. There's one property which is called root directory, which you inherit from the base class, from the NUKE build base class, and from that you can construct additional paths. Like, for instance, here, the source directory would be root directory / source. And notice something, this is the division operator that got overloaded. Something tweeting about that? I get messages. Maybe I should turn on off. Okay. That's a really funny thing, because by doing so, by overloading that operator, we can abstract the path concatenation from the actual underlying operating system. So depending on whether you're on Windows or Unix, we will still construct the correct path using / or backslashes. But you don't have to deal with it by yourself. Of course, you can do this multiple times. You can also get, if you really want, you can still get relative paths. That API looks a bit different now, a bit more beautiful, but that's the old one. And yes. And it's really great for refactoring as well, because if you select a certain expression, and that expression exists multiple times, like for instance, you wrote root directory / source multiple times in one method, and you just select that, then you can extract or introduce variable, and writer would also tell you, okay, there are 5 occurrences, and do you also want to replace all of them? Value auto-injection is about, with other build systems, there's a common practice to have some kind of init target, which does things like, I don't know, grabbing arguments from the command line, or calculating the version of your current build, things like that. In NUKE, this is done for you automatically using attributes. And attributes, they look like that. So a parameter is some kind of input stuff that you can pass on the command line, like for instance -- value hello, and you see down here, that's the terminal. You always have to read it like, if I pass this argument like that, then the value is like this. Okay. For the array, I could say -- array ABC, and that gets concatenated using commas automatic. Not automatically, but there's a target which just prints the parameters somewhere below. But I just want to show you what you actually write on the console and what gets parsed here. So the switch, for instance, will be true then. Configuration, because it's kind of an enum, it's not real enum. You can also use real enumerations, but it's like a class-like enum. It will actually get parsed to the release object. Path, like I mentioned, will always be expanded to the full path version of that. And there's also a solution model, like this will be automatically grabbed from the current solution. And you have full access to the solution. You can modify it, like adding projects, moving them, get the path to certain projects, search for projects, and stuff like that. All on that single solution object. And you can also save that or load, whatever you like. Git repository will get you some information about the repository you're currently working in, like branch, remote URL and stuff like that. And Git version is what I mentioned earlier about, it's about calculating a reasonable semantic version. Is anyone using Git version already? No? I can really recommend that to look at into this. Because the benefit is, with Git version you just have to follow a certain flow. Someone knows what Git flow is? Yeah? So you have a certain branch pattern basically. And Git version makes use of that. So whenever you're merging from the hotfix branch to the master, again, it will automatically increase the patch version, for instance. Or if you're merging from a release/branch into master again, then it will, of course, increase the minor version. Major versions need to be increased manually, I think. But with every commit, you also get a new version number, which is nice. And the great benefit of that is also that if we don't have such an init target, we can still use, we can use those parameters in every target as a requirement. So for instance, publish needs an API key and needs a Slack webhook and stuff like that. But what happens if we invoke publish and then clean gets executed and test and compile and pack and stuff like that? So by doing this requires API key, NUKE will check before execution of any target if the requirements have been met. So even before executing clean, it will tell you API key was missing, which is fail fast behavior, basically. That's something you want, otherwise you're wasting time, right? You forgot to pass the API key, or just wait half an hour just before you realize that. So that's one big benefit. And also because it's real C#, it's quite easy to get information from that through reflection. And so the help text for your build gets automatically extended with the parameters that you define manually. Is that nice? Okay. Target model. I will do this a bit quicker, but as I said before, I would just open that, all of them. Or maybe not. That's okay. But maybe always those two. I thought, and you've seen the depends on already before, I thought it's quite helpful to have those always in pairs. So you can define it either in one direction or into the other. Like for instance, pack depends on compile, but you can also write for compile that it is dependent for pack. Why is that important? Because you've seen it is C#, and if you now inherit from some kind of a build base class that you define yourself, then you want to maybe extend that build still. And having those two pairs allows you to be very flexible about how you extend it. Let's say you want to get into in between compile and pack. You can do this only by using that logic. Okay, otherwise the base class would need to know about what you're doing. That doesn't always work. There are also ordering dependencies. So dependencies that don't necessarily need to be executed, but if they're executed together, then they should be ordered in a certain way. Like, I don't always want to clean, but if I clean, then it should run before restore. Otherwise, I don't know, I clean what restore is doing, stuff like that. Then there are also triggers. Like if I have a publish target and I also want to announce that, then I could define a dependency from announce to publish and then invoke announce, but that sounds a bit weird. If I have a build and I invoke announce, it sounds like it's only about the announcement, but actually it's about the publish step, right? So this is why we have triggers as well.
What's the difference between depends and triggers?
Depends is a backwards dependency, and trigger is a forward dependency.
Okay.
Yeah. Cleanup, yeah, it's like, you know, the using statement in C#. If you mark a target as assured after failure, then it will always execute. Likewise, there's a way to, this is kind of slow here. Likewise, there's the way to make a target swallow exceptions, and it will just continue, and there's no error being reported. Then there are also conditions, like you can check statically or dynamically, or if certain conditions are met. Static means it's checked before any execution of the target. Dynamically means it's checked right before a target. Depends on your use case. Both are valid use cases, I would say. And for the static case, there's also the skip behavior. Well, for dynamic we can't do that, but for static, we could also define if static, or if a target that gets statically skipped, then we can define if its dependencies should be executed or not. Also depends on the use case, but it's there. We can do that. And here's an example graph for a build. Those dashed lines are the ordering dependencies. So soft dependencies, let's say. So clean should always be before compile. The normal solid ones are the normal dependencies, and this yellow one is a trigger. And then you also see, like in the normal flow, if I invoke tests, for instance, then this will invoke unit tests, integration tests, and also compile. Oops. But not clean. However, if I publish my stuff, then I want the full experience, and I also want clean to get executed. And now, because I have this ordering dependency, it also gets executed before compile. So you're very flexible in how to structure how things are done and in which order. Okay, CI integration, and that's a very interesting topic. Probably the most interesting one, or most interesting part. Who is maintaining YAML files for CI/CD? Or maybe not yourself, but inside the company. A few, yeah. Anyone is doing that using graphical interfaces? Graphical interfaces? Like TeamCity, for instance, has a wizard. Okay. What are others using? YAML. Okay, so the first is, I will get to the YAML part in a second, but the first thing about NUKE is that it integrates with most of the common CI systems automatically. Like for instance, this is GitHub Actions, and you see, why do I have two cursors? That looks weird. And you see there's a, is that on the picture? No. Weird.
But now you have only one.
No, it's only
When
one.
you look at
Whatever. But you see the different targets, restore, compile, test, pack, they've been collapsed. And that's because the build is automatically using some kind of service messages that will tell GitHub Actions to collapse that. Right? Also, you see it's properly colored. That's quite difficult to do on the various CI systems, I can tell you, especially also that you can see such a logo, mostly because of the encoding issues. But anyway, going back to the YAML thing, the idea, probably a few months ago, was now we have that, or let's assume you're not personally now have that, but maybe later. We have our implementation in C# now. And why not generate the YAML file automatically from that knowledge? right? Because if we have NUKE, we basically just need to invoke the build. Okay? So here's one example for AppWare, and you do this just with an attribute. You put an AppWare attribute on your build class. You hand over a few images that are known inside NUKE, and you also tell it which targets should be executed. And the major benefit here is we can use the name of operator to have, again, a symbolic reference to the targets. If we rename them, they get updated. And with the next execution of NUKE, it will generate the configuration files, the YAML, the appware.yaml file. And not only for AppWare, but also for TeamCity, GitHub Actions, Azure Pipelines, and AppWare again. Yeah, but those systems are currently supported. AppWare is a pretty simple example, let's say, because AppWare, there's only one agent that's running. There are no dependencies that we can define in between. Azure Pipelines and TeamCity are a bit more complex, but we will look into that in a moment. This is what gets generated from NUKE automatically. And this doesn't look big. I know, it's just, I don't know, 5 lines of code, if you can call that code. It's funny how people say configuration as code, and this is what they mean. Because for me this is not really code. But anyways, on TeamCity and AppWare this looks a bit different. I thought that other slide would come along. But still on AppWare, what we can do additionally, and also this is about the Fluent API, we can say produce, and then we have this, I don't know, way of defining where the NUGET packages are located with that wildcard matching. And that will cause AppWare and any of the other supported systems to automatically publish artifacts with every build. So on AppWare, when the build has finished, you see that the NUGET packages have been added as an artifact automatically. You don't need to do anything about that. Now we come to the more important things. One big benefit of having a CI landscape, let's say, is you can have multiple agents running in parallel. You can, for instance, or you could distribute tests between 5 agents, and each of them executes a different set of tests. Let's say you have 5 different test assemblies, you could assign each of them to a certain agent. But having a build system such as cake or fake, usually it would require some work to actually perform that. Also because you need to skip targets, and it's not that easy. With NUKE you can do this in 3 lines of code, actually. I will tell you how. So the first thing is, it's called partitioning, and the first thing we define is a test partition. It's a of type partition, and also the partition attribute, 2 different types, but never mind. And also along the size. So this could be also the 5 which I mentioned before, but in this case there are just 2 partitions, okay? Secondly, we assign that partition to the test that should actually be parallelized. And the third thing is, from all the test projects that we have, again here we're using the solution object to get all the tests, but using this test partition we can get all the relevant test projects for the current partition. So on the first partition, this call would give us the first half, and on the second partition it would give us the second half. When we have 2, it would be just the first and the second assembly. And that's it. That results in, on Azure Pipelines, for instance, that automatically you have 2 different test executions on 2 different agents also. And they are running in parallel. And you're saving the time of, well, the parallelization, basically. Yeah, I hope I don't need to explain why parallelization is great. But yes, this is how it looks on TeamCity, and here you also see that the first partition executed a total of 239, and the second just 1. Well, this is because for NUKE I only have 2 test assemblies, and the first has a lot, and the second only has 1 test, apparently. But you get the idea. Also, and I would just mention that this has some great potential, especially for TeamCity, because TeamCity tracks statistics for execution times of tests. And so you could even, because TeamCity also has a REST API, you could even automatically distribute your test executions so that they're even, so that not one agent takes 3 hours and the second only half an hour. We could even theoretically distribute that, but that's, I don't know, I still have a life beside, so maybe for later. You remember the parameters that I've shown earlier with the parameter attribute? Because of that, you automatically get this in TeamCity. So there's like for the publish target, we marked API key as being required. You see there's a red indicator for that it's required. Configuration is a closed set of either debug or release. You have a drop-down for that. Checkboxes for booleans, of course. If there's a default value already assigned, and I mean just as a field initializer, you see that default value here where you can change it. Yeah, stuff like that. IDE extensions, well, although I mentioned that you don't need any, I'm not sure if I mentioned that, but usually you don't need to have an extension installed. Because it's just a console application, you can just run it. Anyway, more support can never hurts, right? So, especially for those that are complaining about that tail with the delegate and the expression, arrow, I mean, you have a snippet in all 3 major IDEs, IDEs/editors, VS Code included. And you just type ntarget and it will create you that stuff. Second, this is VS Code. You can execute targets right from where they are defined. So for instance, run target debug target, or from the command palette just by typing the new command and then you can choose. In Visual Studio it looks a bit different. There's the list of targets here, you just double click them, and you can also define to attach to build process, which is basically debug, or to skip dependencies. And this is in Rider/resharper. Resharper works the same. You can just Alt-Enter inside the target and call clean, or debug it, or run debug without dependencies, however you like. And the funny thing is, this is the picture of my notebook, because I have the weird touch bar, and just because of adding this configuration, I also had that icon on my touch bar, which looked very nicely. Yeah, what an achievement. And the third thing for Rider is you have a live graph of what's actually defined, or how you build looks like, how your build graph looks like. And so you see, we remove the ordering dependency, the before, and then the clean gets moved over here to publish. The same example as I had before, right? And yes, global tool. Who knows what a global tool is? From .NET Core side, yeah. So global tools are really nice. I recommend you, even independently of NUKE, to check those out, because what you can do is create a NuGet package, and people can install that NuGet package, and they have a command available everywhere on their system, and you define the command name for that. So for instance, Do I have that still here? No, Nyan cat. Yeah, so like Nyan cat, for instance. You can install that just by executing this, and the biggest benefit of that is that you get auto completion for parameters. So like in this case, you see NUKE, and I just type CO set. And I'm just tabbing, and it completes the target names for me. It completes parameters, like in this case verbosity, and also possible values afterwards, if it's an enum again. And it even knows which targets have already been passed. So for instance, there's, like if you have two targets starting with C, for instance, and you have passed compile already, then on the second time and you type C, it will just pass the second because compile is already there. It was very interesting to implement that completion mechanism. But also it helps you to set up your build project. There's like a tiny wizard, and you just type new column setup, and then it asks for the name, for the location, and you can change it or not, but also for the version, if you want to use the pre-release version, and to which solution it should be added, and stuff like that. Yeah, and those are the applied changes after setup. Like it will, of course, add the build project and the default build implementation. The .nuke file is some kind of a marker for the root of the project. It's usually the same place where the .svn or .git folders are located, but you can change it. I thought this is more flexible, although an additional file, but it's more flexible at the same time. And also there are bootstrapping scripts for PowerShell and Bash. And they bootstrapping because they make sure that the build can be executed, in fact. They will make sure, for instance, that the .NET Core SDK is installed, that the correct version is installed. They also work with the .NET Framework or Mono, if you like, but I recommend the first one. Even with the first one, you can still compile full .NET Framework projects. That doesn't correlate. It's just for the build project, how it's compiled. So I recommend the default settings. And build sharing, the ninth ingredient. So sometimes if you have multiple projects, but they are all building more or less the same, you want to share the build implementation in some way, right? What's the naive approach to do things? Yes, exactly. Okay, some other strategies, maybe?
With NUKE or
In general. Maybe not with NUKE, even if you know one already.
multiple scripts?
But how do you share them?
You could have some sort of linked file that is not copied, but just a link to an existing
Okay.
configuration.
It's similar to Git submodules, maybe? Yeah, kind of, at least. Alright, but Git submodules are awful, I think, yeah. I'm giving a hint. It's C#, right? So how can you share? NuGet packages, right? That's the second one. It's actually a good one, but this still implies some, how to say, some work, some ceremony around that. You might need to version things. You need to publish it properly. It's not a cheap way of sharing. NUKE additionally has something called external files, .NET Global Tools, which is similar to what we've seen earlier. And I haven't looked into that yet, but what seems really interesting are also default interface members. So some of the recent introductions from C#8, where you can implement something inside an interface and therefore have some kind of multiple inheritance kind of thing. And yeah, this seems quite interesting and it also works, but I haven't figured out some good example yet. But I have to explain the global to and the external files approach briefly. So global tools is, I will just explain the use case for what it's made. It's basically for a situation where you are working or there is a core team which knows how all the projects inside the company are built, and all of them build the same. But the users who actually build, they don't need to know about the implementation. So in that case, everything that's needed is you could just hand them over an executable which knows how to build, right? And that's it, and they don't need to care. And so they work the same way like I mentioned with the new global tool, because what you do in your build project is first you say it should be packed as a tool, as a global tool, and also you define the command name. And so if I distribute that to my colleagues, they would just need to call build and everything is done for them automatically, depending on the implementation. But one thing where we had to do some additional work is because if we have dependencies like on JetBrains resharpened command line tools or OpenCover and stuff like that, they need to be shipped with the executable. And that actually, well, you can just call .NET Pack on this build project, and the content looks like this. And beside the executable for the build itself, you also see that the third-party tools are included. That was some additional work to do. But afterwards, it works like I mentioned, basically. External files is more for like, if you still want to modify something, if there's some kind of, that was too fast, but if there's some kind of template which you still want to have certain control. In the first example, no one has control except from passing arguments, maybe. But in this case, what we do, I will show one example. We could have a build project without any build.cs file. Instead, in the build project, we define that there's an external file at this location, so it's a URL, and it should be downloaded and should be put into this path. Additionally, we can define constants like .NET or define some kind of variable like source URL. And if we now look at this file, this build.cs, and it would look like this, it's a template, then you see source URL, for instance, could be inserted here. And because .NET is defined, we will use the restore mechanism using .NET CLI and not MS-Build. So if we want to use MS-Build restore, then we would need to define MS-Build. It is like a cheap, template engine, let's say. And if we call our build, then, and it would be just calling NUKE, then the output would be just like that. The source URL is replaced, and we have the second implementation of the restore mechanism. All right? Okay. And the last ingredient, that's such a lovely topic, because many of the ideas that have been implemented over the time in NUKE have their origin in discussions with people using it, and when we try to come up with an approach that everyone can make use of. Like, for instance, the composition with .when for the CLI tools, that was thanks to Nikita, who's maintaining the Avalonia project. Avalonia is the cross-platform WPF project. It's quite large. It's like 7,000 stars on GitHub or something like that. So I can recommend to look at it at least. Or actually, I have a bunch of stickers with me. That was also a nice surprise at some point. you know, one guy that I met online from Bulgaria, he had a colleague in Munich, and he gave him a bunch of stickers, like 1,000 stickers, and he said, yeah, we need to meet because I got to know him one meetup earlier. And then he pulls out this bunch of stickers and says, here, have it. So working with community is really interesting, and especially if people share their views on things, the issues they have, and I'm very interested in all of them. And yeah, then finally try to come up with something that's meaningful to everyone or to a wider audience. And so, yeah, that's basically it. There are a couple of links. I would really appreciate if you give it a star on GitHub or follow it. I don't care that much if you visit the website because I can measure it. I'm just joking. But yeah, that was it. Thanks, and give me your questions if you like.
I'm pretty surprised by somebody is using something else.
Yeah, that's true. Just the other day, I also mentioned that to some others. It's probably hard, especially for people who haven't used, or who weren't working with build automation before, to realize how painful other stuff is actually. Like MS Build, if you want to do something like that, it's completely impossible, or maybe not impossible, but really, really cumbersome. Yeah. I would say the same for Cake actually, although it made a huge step in the wrong, in the right direction. No, I mean that seriously. Also, I kind of used it as a template, especially for the target Fluent API. But yeah.
What are the requirements for this? .NET Core is enough?
Or .NET Framework, as you wish.
Core
But I recommend .NET Core. Yeah.
Only is enough. You know, if I Docker .NET Core is enough.
Yeah.
Okay. Cool thing to try during the weekend.
Yeah. And tell me if you like it afterwards, please. So, the other day let's see if I have that here. The other day in Vienna, Mantle, where are the comments? Here. Okay, it's in German. Damn it. But he says he tried Nuke just in the same evening when I gave the presentation. So yeah. Alright, I still have stickers in my backpack. Where's my backpack? Lost my backpack. If you want, you can get some, and otherwise, thanks for your attention, and see you maybe later.
So, thank you everyone for coming. Thank you for the guys who left. Yeah, the next meetup is on 26th of February. Stefan will have a session on poly. Maybe do you want to say something about that? So it would be a very short session. The next session would be on and the second section would be on Q#, on quantum computing. I know literally nothing about it, so I'm interested. And once again, thank you for TrustPay. Yeah, do you want to say something about TrustPay?
Oh, we are good. Probably talk more on the other meetup in the February.
Yeah. Okay. So once again, thanks to TrustPay for paying for this booth here and venue. So thank you very much. And of course, thank you for
hosting us.
at Progress Bar. So it's lovely venue. So once again, thank you to all. So there is still some beer.